Welcome to the intricate world of geostatistics, where the measure of spatial relationships is fundamental. A key tool in this field, the Semivariogram, helps us quantify these spatial correlations. Think of it as a function describing the degree of spatial dependence of a spatial random field or stochastic process. The Semivariogram is based on the principle that things closer together are more alike than those further apart, a concept known as spatial autocorrelation. It calculates the difference in values between sample pairs, squares it, and averages it for each distance class. The result is a plot with distance or lag on the x-axis and semivariance on the y-axis, providing a visual representation of spatial correlation within a dataset. Now on to the heart of our discussion, the Semivariogram models. They come in a variety of shapes, each with its own characteristics. The most common ones include spherical, exponential, and Gaussian models. The spherical model, as the name suggests, has a shape resembling a sphere. It reaches a sill, which is the point where the model levels off, indicating that there is no longer a spatial correlation. Next up, the exponential model. This one increases steadily but never quite reaches a sill. It's often used for data with a long-range correlation. Then we have the Gaussian model, a model often chosen for its continuous derivative. It resembles the exponential model but has a slower initial increase in semivariance, which makes it suitable for data with a very long-range correlation. Moving on from semivariograms, let's turn our attention to point Kriging and cross-validation techniques. Point Kriging is a spatial prediction method that uses known values from surrounding points to estimate an unknown value at a specific location. Cross-validation techniques are employed to validate the accuracy of these predictions. The leave one out cross-validation is a popular method where one observation is left out at a time. A prediction is made for this observation, and the process is repeated for all observations. Another technique is the k-fold cross-validation, where data is divided into k subsets, and the holdout method is repeated k times. Each time, one of the k subsets is used as the test set, and the other k1 subsets form a training set. Lastly, we have the technique of jackknifing, which is similar to the leave one out method, but involves resampling and is used to estimate the precision of sample statistics. To wrap it up, remember that the Semivariogram models and point Kriging cross-validation techniques are essential elements in geostatistics. They help quantify spatial relationships and validate the accuracy of spatial predictions, but their effectiveness hinges on the right choice of model and validation technique. So it's not just about understanding these tools, but also about knowing when and how to use them. The right choice can lead to accurate and reliable geostatistical analysis, and that's what makes these tools so indispensable. Enjoy your journey into the world of geostatistics.